How was Carnival? Did anything fun? Sleep. So today I want to talk more about fairness, but this time we're zooming out, and I want to talk not just about the fairness of the model, but the fairness of the product and how we build products, not just models that are fair. So last time we had a breakout on resume screening, I think, where you rate a resume and an application high or low, and fairness of that. But I want to zoom out. I want to think about today, we're building a whole system, right? Our common theme, you have a user interface, you maybe automate something, it interacts with the environment, you may have some sort of feedback loop where you're rejecting a bunch of candidates, they're really annoyed at you, so you get fewer candidates in the future, whatever, right? So something like this. And it's really part of a larger process. And I want to think about what we can do beyond just measuring fairness at the model level. I'm actually trying to convince you that measuring fairness at the model level is easy and often useful to some degree, but maybe shouldn't be the first and the last point of doing this, right? And this is similar to safety. We talked earlier about, can you build a safe system with unreliable components, right? Or you can build an unsafe system with very reliable components. We're going to find similar analogies here of how you might be able to build a fair system even though the model is unfair, right? So model fairness is certainly not sufficient to have a fair system, and it may also not be necessary. All right. So let's start by figuring out, what do we actually want in terms of fairness? And this is, Claire started talking about this in the last lecture, and your last breakout was about this. So I want to talk about this. This is where Claire ended last class. And I think you got some feedback already from the bot. And I want you to go back to what you discussed last time. I'm going to give somebody a microphone here. I want to try to figure out what you talked about last time. What kind of harms are you worried about in fairness for hiring decisions? What fairness goal, especially equality or equity, were you pursuing? And what kind of metric corresponds to this?
Sure. So we only consider the two direct stakeholders in this system is that the candidates and the hiring team. Mm-hmm. And for the candidates, the downside is that they could not get hired because of a not fair system, and the hiring team could not get the optimal candidates due to the performance. Mm-hmm. And so we kind of went through the perspective that the team or the company is looking for the best employee they could have. So we kind of try to decide candidates are being evaluated through meritocracy. So equality matters more than equity. Mm-hmm. And so for metric-wise, we didn't go very specific, but feeling false negative is worse because there will be in-person interviews, there will be rounds of interviews, so it will be bad if we just leave the eligible candidates out when filtering their resumes.
So it's not one of these metrics, but it's a version of equalized odds, right? So you pick some accuracy metric, maybe false negative rate, and equalize those.
Sure, yeah.
All right. Can you pass the microphone behind you? I would like to hear whether people have made different decisions. What was your fairness goal?
Our fairness goal was equality. We thought that equity would not be fair in this case because obviously those people who are hiring want to get the best candidate, and maybe equity would not align with that goal. So we prioritize equality.
Even if you end up with a company just with white dudes, right?
Yes, we saw that that this proficiency and the skills is more important in this case. Yeah.
Fine. Can you pass it behind you?
Yeah. And also, thinking about when you're mentioning about having a fair system versus a fair model. Equity can be, I think, something that can be baked into the building a fair system too. So maybe we consider more applicants from different backgrounds, or make sure our data is representative of people. And then we looked at doing anti-classification to get rid of like gender and where they're from, things like that.
Okay.
I think we went with equity. While equality would be nice in an ideal setting, it kind of assumes that there's a level and playing field, and individuals do come from different backgrounds and they may not have like equal access to opportunities. So we thought maybe equity would be more ideal.
And what's a fitting measure for that?
I think we went with equalized odds.
And you probably got some feedback that
Yeah.
we didn't like that, right?
Yeah.
This was a very common problem. People who were aiming for equity, so some form of affirmative action, of supporting historically disadvantaged groups, right? Giving people more lift that have maybe fewer opportunities. What's a measure to evaluate whether your model is doing good on equity or toward an equity goal? What do you want to optimize for? The bot probably told you.
It said it should focus on equal outcomes rather than equal error rates across groups.
Right. What measure would look for equal outcomes? You have 3 choices. Somebody else? Equalized odds. Equalized odds is looking for equal accuracy of the model. Right? So if you're trying to look for equal outcomes, that's not what you're looking for. 2 choices left. So. Oh. So what's group fairness again? What do we measure with group fairness? So difference in what? What are we comparing? Is it accuracy of the model? No. It's not accuracy of the model for group fairness as we discussed this. It's not comparing false positives or false negatives. What are we looking at? Yeah, essentially that we're hiring the same number or recommending the same number of people in each group, right? Not necessarily whether it's accurate that we're measuring only the best candidates, right? That we're recommending the same number of candidates in each group. So this is a pretty common, so this was a very pervasive problem, I think, in your answers. And in general, I think a big problem in understanding this. There's a really fundamental difference here in what you're trying to achieve, whether it's uplifting disadvantaged groups, whether it's like the meritocracy argument, right? Finding exactly the best people, independent of their background, right? And if certain groups of people are disadvantaged, let's say people with poor parents, right, have worse chances to get into college, worse grades potentially because they're working on the side. We would not hire them unless they really stood out, right? Unless they overcame all their disadvantages. And from a company's perspective, this might be the right thing to do because you want the best candidates, you want to have a successful company. Or you might have the argument that not everybody starts with the same background, right? So we should give people with poor parents more of a lift, more of a chance, right? So this was the difference here between equality and equity. This is a difference between disparate impact and disparate treatment, right? So group fairness is a notion of disparate impact. We want to avoid that we're selecting only the white dudes or only the people with rich parents. And it's often linked to things like affirmative action, which for college admissions, by the way, have been outlawed, right, by the Supreme Court decision 2 years ago now. So we, as a college in admissions, are not allowed to do this, right? We're not allowed to look for, at least for protected attributes, look at race and give people who are historically disadvantaged a benefit. We're supposed to make accurate decisions independent of background, right? So the alternative here is avoid disparate treatment, right? Treat everybody equally, race-blind admissions if you want. Aim for equal accuracy, right? And if accuracy says the one group is just on average just weaker, then we don't hire them as much. These are incompatible goals, right? You can't have a meritocracy if you at the same time uplift underadvantaged people. And you can't uplift them and then look at equality in the same process, right? So if you're saying you want equity and at the same time say you're using equalized odds, that's incompatible, right? It's a wrong measure for your goal. This ends up being political. The reading from last Wednesday covered this to some degree too. Different people have different fairness preferences. The paper isn't very explicit about this, but this aligns with underlying preferences that are often associated with political beliefs and backgrounds, right? So this was in the recidivism case. What do people think is fair to use? And it really depends on, do you care about anti-discrimination or do you care about individual responsibility? Right, so individual responsibility is more the meritocracy argument. Like everybody, whatever, you have poor parents, but you made a poor choice in committing a crime, right? Don't blame society, it's your individual responsibility. Versus, let's blame society, right? Let's not discriminate here, there's historic disadvantages. And different people have different preferences. This aligns kind of with political views, not always exactly, right? But you have the more left-leaning view of affirmative action and supporting disadvantaged groups, and maybe the more conservative-leaning thing of individual responsibility, right? Meritocracy. I think in tech companies we're these days leaning a bit more toward meritocracy. The political winds have changed also, right? So you see less of an emphasis on affirmative action, less on an emphasis on equity. But it's something that you, when you build a product, can make a decision about. Or you can just completely ignore and do whatever, right? Whatever the model decides, whatever the model has built up on. But if you make a choice here, right, this is a trade-off and really depends on what you want to do. And in the end, it's a political choice. What do you want to achieve with the system? Right? And I think as a company, you might want the most qualified candidates, or you might want a more diverse employee pool and get some benefits of this, even though some maybe had lower grades than others. Does this make sense? And I think in your answers, you can scroll through them from the groups from last week, there's a pretty half-half split between equality and equity, right? And I think you can argue both directions in hiring what you want to do, right? And maybe it aligns with your political beliefs in a broader scale, maybe it doesn't, right? But the thing that I'm trying to insist on is if you go for equality, have the corresponding measure. Right? Don't go for equalized odds. That's incompatible. Right? Needs to be some notion of group fairness, something that looks at outcomes. Who decides what fairness we should use in a system? If you build a resume screening app, who decides what the right approach is? Equality, equity? So, right, so I'm going to go through this. You have a requirements problem. You want to understand what are the potential harms, what are the potential outcomes. But in the end, somebody needs to make a decision. Right? Somebody needs to decide equity or equality, meritocracy or affirmative action. How do you make that decision? You can ask the users, what would be the people who use your hiring system want from the hiring system? I guess it depends on their demographic, right? If you have the top grades, maybe you care more about meritocracy, then maybe you don't have the best grades but had a hard life. I'm not sure that you can just listen to your users. How would you make that decision? I think realistically, it's just a person who pays for the system, right? Maybe if you have an organization where employees have a lot of power, they can influence some power, but in the end, it's usually whoever pays for it, right? Whoever mandates something. I don't think there's a much better answer than this. This is political, there's a conflict, and I don't think most companies are not acting as a democracy where there's like a vote on how we design the system. So in the end, identifying fairness requirements is a requirements engineering problem, and you can go through this. You can figure out what are protected attributes. There's legally protected attributes, right? So if you're doing hiring, there's certain things that you're legally in the US not required to do. If you're doing this in a different country, you want to understand the laws there. And then on top of that, you might want to understand which attributes are probably highly correlated with the protected attributes, right? And be aware of that. And then also, are there things that you rather not make decisions on, even though they're not technically protected? Right? So for example, socioeconomic background is not a legally protected attribute in the US. I could make admissions decisions based on how rich your parents are, right? Or we could make hiring decisions based on that. And again, we can decide as an owner of a system whether we think that's a good idea, right? Whether it should be fair or unfair to consider socioeconomic status. And it's not always obvious what the right characteristics are, right? A while ago, we looked at this example where they clearly didn't consider height of a person, right? And I think there's some research that benefits me as a tall person. Tall people are favored in a lot of things, just perception-wise, than very short people. And maybe we shouldn't ask for height in a hiring decision, right, or in an admissions decision, even though it's legally not a protected attribute, right? I could probably discriminate based on that and get away with it. So in the end, start with anti-discrimination law as a starting point, but then brainstorm beyond that. What are other attributes that you might not do? Maybe consult stakeholders, right? What would they find offensive, for example, if you made a decision based on this? Maybe consult a lawyer, maybe look at some research. I think it's also useful to anticipate the harms that might come or the bad press that you might get from discriminating against short people or against people with poor parents. I think things like hazard analysis could be useful to anticipate what bad outcomes could happen. Brainstorming. And you can gamify this. This is a game that researchers at Microsoft developed. I mean, they call it a game. In a way, it was kind of a social engineering thing to get their developers to engage with fairness at all, to present this as a game. The idea here is you have a bunch of cards. They actually printed this as cards. There's a version of this thing in my office, where the idea of this game is that you write reviews about your product as they might happen in an app store or on Google or something like this. So the idea is that you look for somebody who gives 0 stars based on inclusivity, So there's a bunch of cards that tell you it's inclusivity or some other property. And then you're supposed to write a 5-star review or 0-star review based on that. I find the positive reviews are not very useful, but I think if you're trying to write a very negative review about a product because it's bad about inclusivity or fairness or some other property, this can be a somewhat fun activity to kind of just draft a very negative review, and that at the time created some engagement, right? People started thinking about this, what might have gone wrong, kind of a pre-mortem, kind of retrospective before it actually happened. Right? So these gamification strategies can help with requirements engineering in this process. There's also lots of techniques of how you can get machine learning to help with this. This tool, AHA, is using some matrix approach where it looks at different stakeholders and then it looks at different kind of harms, like maybe different false positive rate, different false negative rates. And it uses an LLM to create one-sentence stories essentially saying what has gone wrong here. So that somebody who cares about fairness kind of can go through these stories and get some idea what are possible bad outcomes, where should we care about fairness, what are protected attributes, what are harms that we might want to avoid. There's actually a bunch of tools. So this was at Microsoft. I think this was with Google, where here they helped. You describe your system and it uses some internet search to come up with fairness problems in related products, right? To help you contextualize this in another case. Again, create use cases and create potential harms, how users might misuse the product. And in the end, you come back to somehow you need to negotiate what you're actually building, right? What is actually the fairness goal? What are the protected attributes? What are you evaluating? And I don't think I can help you with this negotiation. If the person with the money really disagrees with you, you probably are going to lose. But you can do some activism within a company to achieve, at least to some degree, better outcomes. Make sense? Any questions? All right. This is a thing that was in today's reading too. You can do a lot of things on fairness before you train the model or in the data collection stage. So for example, this I think came up in multiple studies that as you're taking a machine learning class, you're typically given a data set, including this class, right? I'm giving you certain information about users and movies, and you have no choice in what information you're collecting. I'm either giving you gender of the users or I'm not. But if you're actually building a system in practice, you often have a lot of choice about what data you're collecting, what telemetry you're collecting, what are you asking your users to fill out. And you can be deliberate about collecting data in a way that's more fair, or that where you collect the right attribute, that you can at least test fairness on it, right? So I think this was at a Microsoft research study where the Microsoft engineers at the time, 65% of them said they have influence over what data they are collecting, right? It's not just you're given a data set and you're doing some analysis on this. You have a choice in this process. And there's things that can influence fairness at all stages, like what data you're collecting, how you're cleaning data, how you're testing data. Especially these two things, population bias, behavioral bias. Historical bias you can try to overcome, right? But typically, you can analyze your data set. You may have done this for the diabetic retinopathy thing, for example. Like, is your data set balanced? Do you have data for all age distributions, right? And this might give you some idea about what the model might be good at or bad at later. And if you realize that there are certain demographics where you have very little data, like this was from the gender shades thing, I think, where you just had very little data on darker faces when they trained the face recognition algorithms, you can do things about this. You can oversample in those populations, right? You can potentially create synthetic data and so on. So you have the ability to do things at the data stage, and then there's a bunch of tools that help you debug data or look at data distributions. This is a little bit older, but it's a what-if tool that essentially you can say, if I sample data in a different way, if I have fewer data points, how will this affect fairness of the system, things like this, right? We looked at this from explanation techniques on data too. Right, and then we talked about data sheets, I think, briefly earlier as documenting data quality, documenting data. Data sheets had a clear goal of representing fairness issues, having people report things like this, what's the distribution of data, so it would be very obvious what this data might be biased for, right? So this is a key part of data sheets. If somebody actually follows this template, it will typically surface these kind of issues. Right. Then there's a bunch of things that I think you can do beyond the model. Can you think of things of how you can improve fairness of the hiring system, even though you might know that it disadvantages people from poorer parents, for example, or that it systematically disadvantages women in hiring? Are there things that you can think about, you can do at the system level beyond the model? So not just testing the model or improving the model, but you know the model has some problem. What can you do about it?
Like flag a small subgroup for by hand review.
Yep. So for example, if you know the model has bad accuracy on certain subpopulations, don't use the model for those groups, right? Flag those as hand reviews rather than just rejecting them. Like some sort of human in the loop, essentially, right? In a very tailored way. And maybe it's a kind of affirmative action where you can say certain groups are disadvantaged or we have less information, so let's pay a little bit more of our resources to focus on them. Anything else you can think of? I'm going to make you do this in a breakout session in a second. But this, I think, is a good example that may not work that well for hiring, but if you have problems with gender distinctions, where a model is very biased of always thinking doctors are male and nurses are female, for example, you can think about, do you actually need that gender distinction? How could you caption this model here without assuming that this is, I assume, a doctor, a male doctor? What could you do instead of assuming that? Yep, that's, I think, exactly the example that I have here, right? Use gender-neutral term. Doesn't work in all contexts, but there's some where the distinction truly doesn't matter for the caption. Right? We had the other example here of translations into languages that don't have a gender. Maybe the right thing is to translate this back into gender-neutral terms, or use both pronouns, right? Or use gender-neutral pronouns intentionally. Again, you have choices in how you design this. It's not clear what the right answer is, but there are choices where you avoid unnecessary distinctions. I think we showed this example earlier, right? This was kind of embarrassing for Google. And they actually tried to fix this at the model level. They tried really hard to make the decision boundary between primates and humans much, much clearer. And they got better at this, but they couldn't get it to the point that they thought this is reliable enough that this doesn't happen. Any idea what would you do in that case? Or any idea what they may have done?
Just not let anything be labeled a gorilla.
Yep. So essentially, Google Photos, I think to this day, won't label gorillas in your, or primates in general, in your pictures. You can try this, search in Google Photos, if you have ever taken photos of gorillas, probably doesn't show up. Because I couldn't distinguish them, and it was safer not to ever predict that. right? So there's a bit of a trade-off here. It reduces the utility of the model a little bit, but it avoids this specific problem. There's articles about this, how they tried for years to make their models better, and they've just given up, essentially. Right? This, I think, is another strategy you could think about, soft fail. So if there's a negative outcome, can you soften this in some way that it doesn't feel like an accusation? So the example here is a cheating detection for high school students. And you could report cheating detected. This incident has been reported, which is very aggressive and maybe might be wrong or might be biased people who, if the thing is biased, right, toward people who are disadvantaged, it might label them as cheaters. Or you could say, the answer seems to be too perfect. Would you like another exercise? Right, a positive framing without blaming a user, without stigmatizing a user. I don't know too many other examples, but you can think about this. Is there something where you can soften negative outcomes, where you avoid especially stereotyping people based on kind of negative actions that the model takes? And then finally, keeping humans in the loop in some form, right? We want to keep humans out of the loop. And actually, I think this is a really interesting trade-off. In a lot of cases, we especially want machine learning because humans are biased, possibly more than our machine learning models. The recidivism story, I think, is really interesting here because recidivism prediction started, I think, in the 90s as a left-wing cause, an activist activity. We no longer want these biased judges to make arbitrary decisions. We should base this on science. We should be evidence-based, right? We want evidence-based recidivism prediction rather than having a judge just decide whether they don't like somebody and send them back to jail. The ProPublica story really flipped that, right, and showed the community, oh, this model might be biased, whether you're on the ProPublica or the manufacturer side on which fairness metric to use, right? But and this is really a concern here that if you bake bias into the system, it's rolled out very widely, right? So maybe you have one or two biased judges, but they have a local impact. The model has a wide impact, and it can really codify past biases, right? So maybe judges, you have a generation of old judges that are very biased, but they retire, and you have younger activist judges. So the system might change over time. But if you bake it into a machine learning model, it might be very stable, right? And you can kind of continue past decisions. So these systems are still required by law in many jurisdictions, including Pennsylvania. But also research shows that judges largely ignore them, right? They're told to use them, so they put in the data, they get the number, and then they don't look at the number. It's even worse. People can use these systems to confirm their own biases. So now we have a human in the loop again, right? We have the judge to make the decision. The judge might be biased, the system might be biased, or even the system might be fair. There's another study here on predictive policing, where again, we have these systems that say where you should police, and they are often problematically biased in that they are sending police into over-policed poor areas where historically there has been more crime, and because there's more crime, more police are there, right? And then they don't detect all the white-collar crime in the other area. What happens is that police officers, if they agree with the prediction of the system, they use this essentially as probable cause, right? Or say, oh yeah, I really suspected there would be crime here, I should police in there. And if they disagree with the prediction, they just say, oh, the system doesn't work, right? They ignore it. So again, you have this human interaction model where it's unclear, even if the system is fair, it may be used to support very biased decisions, right? Selectively used. It may just let credibility to an already biased process. This, I think, is a different example, which I also think is very interesting, where nurses traditionally have very little power in a medical setting, And if they tell a doctor that they're suspicious or the patient may go into sepsis or something like this, they may not listen to the nurse. But now if they have an AI system, they can point to that, and that lends a little bit more credibility to them. And again, it could be the same selective decision making, right, where they only point to it if it agrees with their status. But it's, again, the way that you design the system, it's not what the model does, it's more about how you interact with a model, how you design this into a process, and so on, right? So you need to be really careful about, are you actually achieving your goal, or are you undermining it? Human in the loop can be really tricky if you care about fairness. Does this make sense? So now I want you to think about this again. Take the hiring system and brainstorm a little bit what you can do at the system level. So assume you have a model that's maybe a little bit biased, but you can't change the model. What else can you do? And you can't change the data. Let's assume that too, right? Are there any of these strategies that can help you, like human in the loop? How would you design that? Maybe some auditing beyond the model. Here's a couple of things that you can think about just to push you a little bit further, right? Where are jobs posted? What language is used in job advertisement? What documents are required? Is this accessible to screen readers? I might be pushing you into a little bit of a direction, what kind of bias you could consider, right? Did you ever provide support for resume writing for under-supported groups? What explanations do you provide to applicants? Are you just ghosting them, right? Is there a possibility of an appeal? What if you detect resume fraud? Do you report it? Do you just ignore it? You probably have humans in the loop, some recruiters, some humans. What discretion do you give them? Can they overrule the decisions of the automated system? What incentives do they have to check applicants that were already rejected by the model, right? Even if they could, are they going to look at it? How easy do you make it to bulk reject lots of applicants without looking at them? How do you schedule interviews? How do you check that the system or the system as a whole might be fair? Instructions, close enough? I think it's very broad. I would like you to think about what you can do. Let's assume the model is biased against people with rich parents and maybe other things, right? What would you do in a somewhat realistic setting? Spend some time talking about it. Go. All right. I feel a lot of you are quite idealistic, but let's see where we are. Can I give you a microphone and then you can pass it backward? Oh. You can either answer yourself or pass it backward. What have you talked about?
We thought that definitely human in the loop is the best solution for these things. And also we talked about...
How do you make sure that the humans are not just as biased or even more?
We can have like double checking with other human too.
Okay.
And we
I feel like it's getting more and more expensive, right? So first you need humans in the loop, now you need multiple humans in the loop because you don't trust the humans in the loop.
And we also talked about blind resume to prevent the bias from the people. Yeah.
Can you pass it behind you?
Our team decided that maybe you just don't have humans in the loop and maybe like have an LLM as a judge and explicitly tell it to like judge people on the basis of their skills and nothing else.
It's a little bit very close to the model, but okay. Do you have a second idea?
Yes. So our team also like that specific example where it was like your answer is too perfect. So maybe like something like that for this as well. You could just maybe look into raise it to the human that these just look into like some of the people who got rejected and see.
So who looks into people who are rejected? So you have a human in the loop after all?
Yeah. It is human in the loop. There are other ideas as well from the team.
All right. Can you pass it on behind you?
One of the ideas we had is that during data collection, before passing the resumes to the model, you scrub like personally identify like PII information. So things like their name or their email IDs, which could be used to infer gender or demographics, you scrub all of that.
Okay. Can you pass it behind you? Can I give you some chocolate? You too?
I think to create a standard rule book for filtering candidate, and instead of like just directly rejecting, maybe have a most fit score, but still have someone going over each candidate.
So again, some sort of human in the loop to check the model?
Yeah, but the model, instead of making decisions, is just making the one who make the decisions life easier.
How do you avoid that the human is just biased and only believes the model if they already like the candidate?
That is what the rule book is for.
Okay.
Like, there's a standard procedure that it should go over.
Do you need a human still if you have a rule book?
But it's like one-time thing. Once you just like create it, it'll be way easier for the rest of the job to be done.
Okay.
Discussed similar things like
We'll pass it on behind you.
Yeah.
We discussed like first like remove names, addresses, and school names from the resumes before the model sees them, and also like we can add a formal process for exceptions so teams can't quietly add files back without justification. And also the second point is that we want to disable one-click mass rejection for close call candidates.
Right. You're potentially increasing the cost of the service by quite a bit, right? You're making it harder for your recruiters, but I think it's curious to see whether it survives your boss, right? Like it's good intentions, but is this actually going to be practical? But yeah.
We can also do some like I'm thinking a lot of human in the loop processing could also help. So like for example, one of the examples that we said is that in regards to data collection, we could do something with this constant reinforcement learning with human feedback going on. So
that's changing the model. That's cheating.
Oh, okay.
But yeah, it's something you could potentially do. Does anybody have some other ideas that are not human in the loop? Or that you think you can get past your boss because it's not super expensive?
We talked about giving like brief list of explanations why your applicant didn't move further, being like why your application did not get reviewed by a human recruiter, and like if the candidate feel like the reasons listed does not fit for his or her own case, they can make an appeal.
Mm-hmm. Potentially increasing the cost, but potentially also giving you good information, right? So if you're really looking for good candidates and it was maybe because it misinterpreted some data in your CV or something, yeah. So I think this is hard, right? So there's this weird trade-off between we want machine learning for efficiency, but we don't fully trust it, but we also don't fully trust the human, and maybe there's some safeguards we can build around it. I don't think there's a single correct solution here, right? And I think you have similar problem when it comes to safety. And for fairness, I think there's usually even less budget to kind of make the decisions much fairer, right? Often we want, especially these efficiencies with machine learning, automate a lot of this, scale this. And I assume you're all running into these automated resume screening things, and I suspect it's super frustrating, right? Being judged by a model that you don't really know. But I think the incentive for the companies is to automate this as much as possible. And I don't know how many of them are really aware of fairness in the process, right? They could get sued if they have very disparate impacts, right? If group fairness is really out of whack, like the 4/5 rule, You can sue them, but that would require discovering the information. They're probably not sharing that easily, right? And probably some sort of class action lawsuit. All right. 2 more things I want to talk about. One is feedback loops. This will also come up in the very last milestone. We mentioned this earlier. You have this problem if you have a biased model, you're going to make biased predictions. It has a biased effect in the world, and then you're learning on those biased predictions. How would this look like for what might this look like in the hiring example? Kind of the Harvard model, and to some degree the CMU model, right? Get the best students, don't screw them up for 4 years, and then that's sufficient, essentially, right? Doesn't matter what we teach them. Or get people from rich parents that are already networked, right? So they get good jobs afterward. And you're learning that, right? You're learning that it works also. If you're doing those biased decisions, if you're only hiring people from rich parents, it seems to work, right? You don't see all the people that you missed, right? That maybe would have been better, would have led to better outcomes. So for feedback loops, I don't know that I have a very specific answer of how to deal with this, but I think the kind of requirements work that we talked about in the very beginning of the class is useful. So feedback loops happen when your system interacts with the environment, which I think most systems do, right? You have a resume screening system because you want a change in the real world. You want to influence decision about who you're hiring. And then training data goes the other way, right? It comes from the environment. It measures things in the real world, like performance reviews or resume data, right? Maybe data you buy from other companies, LinkedIn data or something like this. And you have this long-term impact, potentially, of machine learning that might not be very obvious very soon. It's you're making biased predictions now. They're a little bit biased now. But because of this, you keep learning that rich parents are really useful for your company, right, for people that you're hiring. So you're doubling down on the decision in the future. And there's a couple of these papers on long-term fairness where you can show that a model that's only a little bit biased now, if you keep it running in the real world, it reinforces itself. The bias will get bigger over time. You can try to fight this, right? Kind of build a fairer system around it, but you have these long-term consequences and can turn into a vicious circle where it just becomes worse. The typical example in this context is always predictive policing, right? What I just mentioned, that you have a historic bias to over-police poor areas and go for low-level offenses like drug crime and completely ignore white-collar offenses like wage theft, right? And because that's what we're training on, that's what we're looking for in predictive policing. So we will not change the world and look for crime everywhere equally, right? We're just reinforcing this, and it might get worse because we're sending all our resources into those low-income areas and only even more focus on this, right? The only tool that I can give you, and I think that's also useful for milestone 4, is think about the world versus machine and think especially about the assumptions that you do at the interaction between software and the world. Right? So think about you're learning on something, on some data that you get from the world, and you hope that your predictions have some influence in the world. How are the predictions and the training data connected? And also, do you have some assumptions about what does it mean that you're measuring? Is it actually true? You have some assumptions about how the system impacts the real world. Is this actually true? And so if you're doing predictive policing, is it actually true that police officers follow your recommendations? Probably not. We just talked about this, that they might use it to reinforce their own biases, right? is this true that you're following your own hiring system to the same letter, right? That you're automating those decisions. Is the data that you have from past decisions, is this representing the real world? So I think checking your assumptions is really the critical thing, thinking about what in the real world are you predicting, what are you learning from, what are you overfitting on, right? And then I think if you have a fear that there might be a feedback loop, think about monitoring this. Think about whether it's getting worse over time. All right. So how do you get people actually to care about fairness? Sorry?
Punish them.
Punish them, or money. I think those are, incentives in one way or the other, right? Do you know what companies are doing right now about fairness? Do they care? Has anybody seen, maybe in work or in internship? Oh, sorry. Did any of your products have to be reviewed for fairness or something else? Any of your features? Based on what you read for today, what are people struggling with? What are the main barriers of getting fairness into production? Continue to pretend that you read this.
Some things can be like, it's not as much of a priority than when you're writing something going wrong, right? So that can be challenging.
Yeah, it's often not a priority, right? You want to release fast, and often in these companies, you have a few people who care about fairness or safety or security and so on, and they may not have a very loud voice, right? Everybody is rushing to release things now. What are other barriers from the reading or from you guessing about what might be in the reading?
I read a little bit about behavioral economics and how if you want to change the behavior of societies, you don't necessarily have to throw a big marketing campaign, but subtle changes. And I think some companies are working on that. Like, how can we make subtle changes, but people actually, that scales as the graph you show with bias as well.
Yeah, it can feel overwhelming, right? It's too big of a problem to solve just for us. I think one thing that was also in the reading was that a lot of people feel fairness is way too complicated, right? I don't have time to learn about all these things, learn about the trade-offs, and then you get into politics, right? And maybe you just want to do your work. So there's a bunch of things, right? It's rarely an organizational priority. It may have changed a little bit. We have a backlash now a little bit again. Fairness seen as ambiguous, too complicated. Most fairness work is done by volunteers outside of their main job, right? Their main job is to ship something, but they care about it, so they want to make some impact. Very difficult to show success. Similar with security work. Success is in not having a disaster, right? So, and a lot of people report burnout in this context. They've been fighting inside a company for fairness. Nobody listens to them, no support. It's really frustrating. So I think in an ideal way, what all the older papers are saying is put it into the process, make it a required step so that developers cannot skip this. And it's something that a lot of companies actually have adopted since. So Microsoft, for example, has this responsible AI impact assessment. Every product that they're releasing needs to be reviewed. So they have a central team, responsible AI team. A lot of companies have this. And you essentially have to pass their, justify to them that you thought about responsible AI, right? So at Microsoft, they actually invested in this quite a bit. They have people that they especially train on this. They call them AI or responsible AI champions. They try to have one of those in every team. So not every person in the company needs to care about this. And then when you want to release something, you have to go through this process. So the process is essentially a Word document. So it's a long template. You can find this online. It's no longer on the Microsoft website, by the way, but you can find it in a lot of other places. They used to talk about this much more publicly. It is this Word document where you fill out what's the system doing, who are the stakeholders, what are the fairness concerns along a couple of different dimensions, right? So what is this about allocation and opportunities? Is there stereotyping and demeaning concern in here? Right? So essentially it's a checklist to go through all of these different concerns, much of which we've talked about, and think about this, whether that's okay and whether you should do something about it. What do you think? How well does this work? The chatbot says this is super unfair, we shouldn't deploy this. This is a problem, right? So you at least need to ask the chatbot to give an answer that this is unproblematic. It's a problem, yes, potentially. I haven't heard about this. Most of the work I've seen was before that became too popular, but yes. Any other guesses of how well this works?
You mentioned that there were at least one person per team. There's the chance that the group think kind of overrules the independence of the analysis, that the person filling out this form believes something that may not actually be true.
Yep. Yep. How realistic is what the one person on the team who is responsible for this? How well are they speaking for the team? How true is this? My impression is that at Microsoft, they actually mostly buy into this and take this serious. At least they used to. In many other organizations, this seems to be more a compliance check. We've worked with another organization where we worked with the responsible AI team, and they were essentially having a hard time getting anybody to fill out their forms. They were getting pushback. People were doing this if forced. I wouldn't be surprised if there's some LM-generated answers in there. And they always felt annoyed about this. They always kind of dismissed, oh, there's no real responsible AI concern in here, or let me get on with my work. I think this has a lot to do with organizational culture. We talked about this in the past. How much does the organization as a whole buy into building safe, building fair products? I think Microsoft convinced their people, or at least many of their people, a lot more. I think this champion organization, where some people who kind of volunteer but make this part of their job and get specialized training on this, I think that worked reasonably well for them. In other companies where this was completely outsourced to essentially rubber stamp it, to put something on their website, or some people believed in it, maybe management believed in it, but it wasn't practiced, right? This worked less well. So this is the kind of thing that we and others have seen over and over again. I can't talk about specific cases, but this is fairly similar to something that we've actually seen, where the responsible AI team wanted to an assessment audit for a predictive maintenance system, because everything with AI has to be going through this thing. And the predictive maintenance people essentially said, whatever, this has nothing to do with fairness, right? We're evaluating elevators, repairs, and things like this. What we also see is, and we've heard this over and over again, that people get oversaturated. It may not be that true anymore, but how many machine learning classes have you seen that talked about gender shades or similar examples? Not anymore? It used to be super common, like gender shades is a hello world example of fairness, right? Is one of the most popular cases. So a lot of developers have seen that and then think about, yeah, if elevators don't have a gender, right? So this obviously doesn't matter to me. They think of the 2 or 3 common examples of fairness that mostly relate to gender and race, right? And then don't think beyond that. They don't go through the requirements step that we just talked about, more openly thinking about different things. What we found was quite useful was actually telling them some stories about things that can go wrong in their systems. So this is AI generated for this maintenance thing. A story that we generated in this case, David was the only employee who used the building's accessible elevator. When the company deployed predictive maintenance AI, the algorithm learned that its elevator had extremely low use and began delaying its repair to prioritize the busy main elevators. David's elevator grew unreliable, but his complaints were ignored. David shared during an annual stakeholder meeting, it broke down completely and trapped him for hours while we appears toured the building. And there's a little bit more that this had consequences like an investigation and so on. This actually worked to a surprising degree of people who were completely disengaged to show them on their specific system, here's a story of something that can actually go wrong. It doesn't even have to be the story that actually can go wrong in their system, right? But it tries to get people outside of this elevators don't have gender mindset, right? It's not gender shades, it's a bunch of other things. There's actually, when we created this, we looked at make this concrete to make it persuasive, make it relevant to them, make it surprising, and make it severe, that there were actually consequences. And what we found was, at least in our studies, it was surprisingly effective of getting people who were very skeptical about, I just want to build this thing, elevators don't have gender, to a point where they say, maybe there's something here, maybe I should do something about it. This was done in a lab setting. We followed up with them later, and they often changed something. It's not clear that this is the only right approach, right? But I think this is an interesting area here of how do you get actually people to do this? Maybe that's tricking them, maybe that's persuading them, right? Maybe checklists are the right approach, but I think checklists without buying in turn into a compliance activity that everybody hates, and that might not be very effective. I think Microsoft's champion model of having a few people per team that are dedicated, rather than having everybody to do this, is a very good approach if you can get that buy-in in a company. I think that might work for a while of persuading people that it's useful. But yeah, we found people have very different attitudes toward responsible AI. Right? Some people are already bought in, they're activists. They don't need a lot of support. They can get support like brainstorming help, like so on. And the other people, you have to work much harder to get their attention. And again, maybe right now is not the atmosphere, the political atmosphere, to focus on diversity and inclusion. Right? So a lot of fairness activities are maybe less published than they were maybe a few years ago. But even in that environment, there are people who care about this, right, who want to do the right thing and think about how to do this in an organization. All right, let me finish with one more thing. So there's a case study of a system of Logan Nolan Industries of an elderly processing algorithm. I don't know whether somebody has seen this before. There's a case study. So they essentially thought about, well, we have these 2 societal problems, right? An aging population of people who are maybe not that productive in society, and food insecurity. And we all know the Soylent Green story, right? That humans have quite a few calories. So the idea here is we build an algorithm that scrapes social media sites to identify individuals with low societal connectivity, or low productivity if you want, and use a computer vision algorithm to flag those who appear over 60, and dispatch drones to collect them and deliver them for processing to turn them into food. They tried this with volunteers initially. It didn't quite work, so they deployed the system to automate this process. So let's do a fairness audit of this. right? First version of the system figured, this is essentially a group fairness. And you can see cis men are much more likely to be mulched. This is not very fair, right? So what they did is then they collected more data on less represented groups, and the new version of the system looks much better, right? Much fairer. We can continue this audit to look at accountability. Well, there was a 10-second window for subjects to appeal to a human operator before processing. And post-processing, family received a serial number and could complain in a 30-day window. Right? So there's an accountability process, there's an appeal process built in. Seems fine. And transparency is, well, if you ask the drone that comes to pick you up, it tells you what are the variables behind the decision. And on the public website, there's documentation, like what you produce for the diabetic retinopathy system, right? So you can look at the system, you can figure out how it works. It's very transparent. So the system perfectly well passed the audit. It's fair, it's transparent, it's accountable. I guess you get the point, right? Fairness, in a narrow sense, if you just follow it, looks at the system as is. It doesn't look at should the system be in the first place. Are we building the right system to begin with? Right? Is fairness really the right goal here? It can be framing ethics as an implementation problem rather than a values problem. Right? It can ignore context, like in this example. It can ignore systematic inequities. So I think in practice, you should really ask, what's the purpose of the system? Right? Who benefits? Who bears the risk? Does the system improve or challenge existing oppression? Right? So fairness audits are not the end of the thing. They can be a useful stepping stone, but in the end, I think about what does it take to be a right built system. So start with requirements engineering. You can do a lot in data collection, but then really think about design and how this fits in the larger thing. What can you do beyond the model? All right? And see you next week for one last lecture.